We are tied to the ocean, and when we go back to the sea, whether it is to sail or to watch it, we are going back to whence we came. That's Rachel Carson. Hello, and welcome to the Deep Dive.
Hello.
Today, we're embarking on a truly deep journey, billions of years into Earth's past, exploring some of the planet's most ancient structures found right here in India.
That's right. We're diving into the fascinating world of stromatolites. And these aren't just, interesting rocks. They're structures built by some of the very earliest life on Earth.
And they played a huge role, right, in shaping the planet we live on today.
Absolutely pivotal.
This deep dive is inspired by some really excellent material shared with us, including a recent article from the Indian Express that sparked quite a bit of discussion around a specific find in the Himalayas.
And our goal here is basically to help you cut through the complexity, sort of extract the essential insights from these sources.
Yeah, to understand the incredible significance of stromatolites for Earth's history, its geology, and, well, even our own existence. So whether you're maybe tracking this topic for exams like the UPSC, or you just possess an insatiable curiosity about Earth's deep past, or maybe you're keen to learn about India's unique geological heritage.
There's a profound story waiting here.
There really is.
And look, if this deep dive helps you connect the dots or maybe sparks some new questions, please do consider liking this video, subscribing to our channel for more explorations.
And leave your thoughts or queries in the comments below. We really value that engagement. It helps us understand what matters most to you.
It really does.
Okay, let's unpack this then. Let's go back, way, way back. Imagine Earth, maybe 4 billion years ago. This wasn't the blue and green planet we know now.
Not at all.
No complex life, no forests, and crucially, the atmosphere, almost entirely devoid of oxygen. What do the sources tell us about that early Earth?
Well, the material we've looked at describes a very, very different world. The atmosphere was thick with greenhouse gases, think carbon dioxide, methane. Very different from today's nitrogen-oxygen mix.
Right.
For roughly the first half of our planet's existence, oxygen was essentially absent in the atmosphere, even though sunlight was constantly splitting water vapor, creating tiny bits of oxygen.
But it didn't stick around.
Exactly. It was quickly consumed by other elements, other gases, particularly methane, and it got locked away in the Earth's crust. It just couldn't accumulate to any significant level.
So how did we get from that, suffocating oxygen-poor world to the oxygen-rich atmosphere that allows us to breathe today? This is where it gets really interesting, isn't it?
This is where the story really takes off.
Microscopic life enters the picture.
Precisely. The sources introduce us to these ancient microbial mats, primarily made up of cyanobacteria. You might know them as blue-green algae living in shallow, sunlit seas.
Okay.
And these tiny organisms possess this, revolutionary ability, photosynthesis, taking in CO2 and water and releasing oxygen as a byproduct.
And as these mats grew, they weren't just living there, they were actually building something.
That's the incredible part, yes. As these microbial communities thrived, they would trap and bind sediment particles from the water around them, little bits of sand, mud, and over vast stretches of time, layers upon layers of these trapped sediments, often cemented by things like calcium carbonate precipitates, would build up.
Layer by layer.
Layer by layer, creating these layered, mound-like, sometimes even reef-like structures. And these structures are what we call stromatolites.
So essentially layered rocks built by ancient microbes. Is that a fair summary?
That's a very fair summary. Think of them as bioconstructed sedimentary formations. Now, there is some, scientific debate about the exact classification.
Right, I saw that. Fossil or something else.
Exactly. Are they true fossils with preserved organic bits, or better described as biosedimentary or organosedimentary structures? Dr. Ahluwalia, for instance, makes that distinction: preserved organism versus preserved structure. Dr. Ray prefers organosedimentary. But the core point everyone agrees on: they are direct evidence of early life's presence and its activity. Dr. Jagmohan Singh even refers to them simply as among the oldest fossils, indicating early single-cell life.
So the link to life is undisputed, regardless of the label.
Absolutely. The key takeaway is their origin with life and their incredible age.
And these, humble-looking layered mounds started popping up in shallow seas billions of years ago. What was the big consequence of this happening globally?
This is the turning point for our planet. It's huge. As these photosynthetic cyanobacteria living in and building these stromatolites kept releasing oxygen,
Yeah.
that oxygen started to accumulate. First, it reacted with things like dissolved iron in the oceans. You get banded iron formations from that period. But then gradually it started building up in the atmosphere itself.
And this wasn't a gentle, slow change, was it?
Not at all. It seems around 2.4 billion years ago, the rate of oxygen production just outpaced its consumption. This led to a dramatic, relatively rapid increase in atmospheric oxygen.
And that's the Great Oxidation Event.
That's the Great Oxidation Event, or something's called the oxygen catastrophe.
Catastrophe. Why catastrophe?
Well, because oxygen was actually highly toxic to most of the life forms that existed back then. They were anaerobic. They didn't use oxygen. It poisoned them. So for them, it was a catastrophe.
Wow. Okay. So what did this world-altering event mean for the future of life on Earth?
It completely reshaped the planet's chemistry, fundamentally. And it set the stage for, well, everything that followed.
So
This shift from anaerobic to aerobic conditions created an environment where new forms of life could evolve, life that could use oxygen for respiration, which is a much, much more efficient way to get energy.
right.
As Dr. Ritesh Arya points out in the sources, this monumental shift, which we see preserved in the geological record, ultimately paved the way for the evolution of complex, multicellular organisms.
Like the trilobites, dinosaurs.
Exactly. Trilobites, dinosaurs, eventually mammals, and then us. You can draw a direct line. The very air you're breathing right now.
Is thanks to these ancient microbes.
Largely, yes. Thanks to the work of those ancient microbial mats and the stromatolites they built billions of years ago.
It is genuinely mind-blowing to think our existence is so deeply linked to these ancient microbial mounds. Now, okay, the oldest known ones are in Australia, right?
Yeah.
About 3.6 billion years old.
Correct. Western Australia.
But India has its own incredible story, a really rich record of these structures.
Yeah.
Where can we find evidence of this ancient life here in India?
Oh, India is an absolute treasure trove. They span vast geological timescales in huge regions. The sources list, well, numerous locations across the country.
Like where?
We find them in the ancient Vindhyan and Kudapa basins, in the Aravalli Supergroup, which is one of the world's oldest mountain ranges.
Wow.
And really significantly, they're found uplifted high into the Himalayas, places like Mussoorie, Nainital, parts of Himachal Pradesh, Sikkim.
High in the mountains. How did they get there? We'll get to that. Where else?
There are also really important sites in the Dharwar Supergroup in Karnataka. Those hold some of India's oldest, maybe around 2.5 billion years old.
Okay, really ancient ones there.
Yes. And others in Rajasthan, like Chumarkotra and Zawar, and further south in the Bhima Basin. It really shows how widespread these early ecosystems were across what became the Indian subcontinent.
And finding them high in the Himalayas, as you mentioned, that tells us something fundamental about India's geological journey, doesn't it?
It absolutely does. It's a direct consequence of plate tectonics. Many of those stromatolite formations in the Himalayas, like the ones in the Coral Belt,
Yes.
they were originally formed in shallow marine waters, specifically the ancient Tethys Sea. Millions and millions of years ago, before the Indian subcontinent even began its journey north to collide with Eurasia.
So these structures were happily forming on a seabed, underwater.
Precisely. Building up layer by layer in warm, shallow seas. And then when the Indian tectonic plate started moving northward and eventually slammed into the Eurasian plate.
The collision that formed the Himalayas.
Exactly. The immense forces involved in that collision folded, faulted, and uplifted those ancient marine sediments, including the stromatolites, thousands of meters above sea level. Dr. Arya mentions finding shallow marine deposits at altitudes of 5,000, even 6,000 feet.
Incredible. They're literally a record of deep time and continental collision, lifted sky high.
That's a perfect way to put it.
Okay, this brings us nicely to a specific recent story, the one highlighted in the Indian Express article. This large outcrop found in Chambaghat, in Himachal Pradesh's Solan district. What makes this particular find noteworthy, at least from the perspective of the team who found it?
Well, Dr. Ritesh Arya, who is involved in publicizing this discovery, is particularly excited about the sheer scale and accessibility of the Chambaghat site.
Scale.
Yes, he describes it as a whole hill covered in stromatolites, not just small samples you have to hunt for, but a massive visible display. He sees it offering an unprecedented opportunity for study, but also for public engagement and education.
Okay, that makes sense. And the age?
He estimates this specific outcrop to be at least 600 million years old. possibly older. And Dr. Jagmohan Singh also highlighted its impressive scale compared to some other known sites like Shamar-Kotla.
But the source material also presents some differing scientific perspectives on the overall significance of this specific find.
It does, and it's really important to understand these different viewpoints which the article lays out. Other experts emphasize that while the Chambaghat site is visually impressive, maybe even spectacular, it isn't necessarily a new discovery in the sense that Kroll belt stromatolites were previously unknown to geologists. They've been studied for a long time.
Right.
Dr. Vibhuti Rai, for instance, argues quite strongly that calling it a significant or rare discovery or suggesting it's the oldest evidence of life is, in his view, inaccurate. He actually used the word hoax in the context of it being portrayed as a groundbreaking find.
Strong words.
Yes. He points out, correctly, that stromatolites are common across India and globally. And crucially, India's oldest examples, like those in the Darwar region, are far, far more ancient, around 2.5 billion years old.
Compared to the 600 million or so for Chambaghat.
Exactly. So in terms of finding the earliest signs of life, Chambaghat isn't it.
And Dr. Ahluwalia also offered some clarification in the source.
He did. Dr. Ahluwalia acknowledges the Chambaghat outcrop is magnificent in its preservation, great for exhibits and education. But he agrees Kroll belt stromatolites have been known for a while.
And he made a point about age within the Himalayas.
Yes, he notes that the Kroll belt formations, where Chambaghat is located, are actually among the youngest stromatolite-bearing sequences in the Himalayas, not the oldest.
Interesting.
And this particular site likely features younger types of stromatolites. They often show these gentler arcs, clear lamination, hemispheric shapes, which contrast with some of the older forms found elsewhere, which can be branching or columnar.
Okay, so let me see if I got this right. The Chambaghat find is exciting because it's big, it's visible, it's great for showing people, potentially for education, maybe tourism.
That seems to be Dr. Arya's main point, yes. Accessibility and scale.
But from a purely scientific perspective, looking at the broader picture presented in the sources, the consensus seems to be it's not the oldest in India, not even the oldest in the Himalayas, and the existence of stromatolites in the Kroll belt wasn't unknown. Is that fair?
That seems to be a fair reflection of the different perspectives presented in the Indian Express article. It highlights a difference perhaps in what constitutes significance. Is it scientific novelty and extreme age? Or is it scale, preservation, and accessibility for public understanding?
Both valid points, depending on your focus.
Precisely.
Okay. But regardless of whether a specific site is the absolute oldest or the newest discovery, these stromatolites, wherever they're found, represent an irreplaceable record. A record of our planet's history, and specifically India's deep past. What concerns are raised in the source material about actually preserving these crucial geological sites?
This is a really critical point raised in the sources. Dr. Arya voices a major concern, one shared by many geologists. These incredibly valuable geological sites, including stromatolite locations, are often inaccessible, often unknown to the wider public.
So hidden away.
Exactly. They might be studied by researchers, mapped, sampled, but then they effectively get, as he puts it, stored away. There's often no concerted effort to make them visible, understandable, or protected for local communities or visitors.
That phrase, stored away, really hits home. It implies neglect almost.
It does underscore the risk, doesn't it? And there's a strong push from researchers like Dr. Arya and Professor Ashok Sani for active preservation efforts, because these sites are vulnerable. Well, natural erosion, of course, over time, but increasingly they're threatened by human activities, construction projects, road building, mining operations, sometimes just general neglect or vandalism.
Right. The source mentioned Chambaghat.
Yes, Chambaghat in Rajasthan. It's used as a poignant example. It's a site with incredibly old stromatolites, about 1.8 billion years old. There's even a geological park there, but it still faces significant threats from nearby mining interests.
So even having a park isn't always enough.
It seems not. Without robust protection and maybe wider recognition of its value, without that formal safeguarding, these unique windows into deep time can just be lost forever.
And specifically for this Chambaghat site, what kind of preservation is being advocated for there?
Dr. Arya is a passionate advocate for creating a geoheritage park at Chambaghat. That's his vision.
A geoheritage park, what would that involve?
The idea is to collaborate with local schools, with tourism bodies, with the community itself, to make the site an active educational resource. He talks about wanting these rocks to be teachers.
I like that.
Yeah, helping people, especially children, connect directly with this vast history of life on Earth, right there on that hillside. He's actively seeking local support and awareness.
Any hurdles mentioned?
Well, the article does note that parts of the hill are privately owned, which adds a layer of complexity to creating a formal park. But he's hopeful for wider recognition, maybe even aiming for UNESCO status down the line.
And Professor Sani supports this kind of preservation effort.
Strongly, Professor Ashok Sani echoes this call. He emphasizes that preserving these sites isn't just about old rocks. It's essential because they mark this absolutely critical juncture in Earth's history.
The oxygen point again.
Exactly. The moment when oxygen production by these tiny microbes began to accumulate, making the evolution of all subsequent complex life possible. Preserving these sites is, in a very real sense, preserving the foundation story of complex life on Earth.
It really sounds like a critical moment then, a call to action to recognize and safeguard these ancient treasures before they disappear and take their incredible story with them.
It absolutely is. These aren't just rocks, you know. They're monuments built by the earliest life we know of. Understanding them is vital to understanding our planet's evolution, deep time, and the very air we breathe. And for those preparing for exams like UPSC, or really anyone seeking to be well-informed, understanding the significance of these sites, the science behind them, and the ongoing efforts to preserve them is incredibly valuable knowledge.
So we've taken a truly deep dive today. We've imagined an oxygen-starved early Earth. We've met the microbial engineers who built the stromatolites, layer by patient layer.
We witnessed the planet-altering Great Oxidation Event, the oxygen catastrophe for some.
We explored India's incredibly rich landscape, dotted with these ancient relics from Karnataka to the high Himalayas.
We delved into the excitement and also the scientific debate surrounding that Chambaghat find, as presented in the Indian Express.
And we've touched on the really vital need for their preservation to keep these teachers talking to us.
It's just such a powerful narrative, isn't it? It highlights the immense power of even microscopic life acting over billions of years, and the deep interconnectedness of Earth's geological and biological systems. Understanding stromatolites gives us this tangible link to deep time, to plate tectonics, and to the fundamental processes that ultimately made our planet habitable for complex life.
So here's a final thought to leave you with. Given that these ancient, simple structures, built by microbes, literally created the oxygen that allows all complex life, including us, humanity, to exist, does understanding their legacy change how you think about the microbial world around us today? Or perhaps even our own responsibility for the environment we've inherited?
It certainly offers a profound perspective, thinking about the long-term impact of life, however small it seems, on a truly planetary scale. Definitely something worth contemplating.
We strongly encourage you to explore the source material from the Indian Express and other resources to learn more about this absolutely fascinating topic. If this deep dive sparked your curiosity, if it helped you better understand the story of stromatolites in India,
please do like this video, subscribe to our channel for more deep dives into important topics like this.
and please share your questions or thoughts in the comments below. We genuinely appreciate you joining us for this exploration.